Good, thank you. And thank you for this opportunity to talk with a faster group. And it's fun to follow John, because I'm going to talk about a much more practical set of issues that he framed so well in a much more conceptual way. So this, I think, is the perfect order. Primarily, what I'm going to talk about is focused on the OSTP guidance memo with respect to digital data and publications produced under federal funding for research. But the idea is in implementing that, to conform with the OMB guidance memo with respect to machine readable and all of its other provisions. So this is focused primarily on science data, but the intention is that the platform in the end will be usable for the full spectrum of government information envisioned in the OMB memo. And since NIST's mission is in standardization, that was one of the first things we thought about when we thought about how to respond to the requirements of those two memos. And what we are attempting to do is to generate a reference implementation of what amounts to a metadata registry that would allow for interoperability across more than one entity and perhaps more than one agency. And that's really why I wanted to talk to this group today. We're calling this a common access platform, and you'll see in a minute what we mean by that. So if I could have the next slide. But this just gives a sense of the problem space with respect to providing access to the products of data. And you can see these three pyramids are data, software, and publications. And I'm going to focus for the moment on the data pyramid. And in the pyramid here at NIST, the scientific data are of three general categories. At the base of the pyramid is perhaps the most abundant category, and that is the research data that's being used by our scientists and technologists on a day-to-day basis as part of their research activities. A certain fraction of that data could be usable by others, but much of it is in the works and is imperfect and so on. So it's not complete, and initially we're not focusing on that. At the top of the pyramid are reference data sets, and at NIST, these are data sets we call standard reference data. These are data that are highly vetted, closely characterized, designed for reference use by others, currently available on the web, in an imperfect form, but available. So it's this end of the pyramid that is easiest for us to address in our initial response to OSTP and OMB. And so for the most part, what I'll talk about focuses on those sorts of data sets, although the intention is that the implementation would allow us to work our way down this pyramid, including additional categories as we go. And so it's a phased implementation of the access requirements that we have in mind. All right, so that's at the top. At the bottom of this is the problem that I think probably most of the agencies have, not just NIST, and that is that the data that we're talking about are not located in any single repository or even any single geographical location. So we have some of our data sets here on public servers, some of them on internal servers, others on NIST servers that are located nearby or even not nearby, but operated on behalf of NIST as well. So even the NIST storage is highly heterogeneous and somewhat distributed. But our publications may well end up in PubMed Central. There are community repositories that host some of our data. And then, of course, like many of the other agencies, much of the data is moving into cloud storage as well and cloud solutions. This basic problem that an agency is given the goal of providing a single point of access to all of their data sets, although the data sets are located in many different repositories with many different storage strategies and located in a wide variety of places. And so that's the basic conceptual problem, is how to provide that access. And the common access platform concept that we have in mind is to address exactly that problem, how to integrate access to data at a wide variety of repositories. And I should add that our assumption is that this distributed solution for data storage and access is not going to change, that we do not have plans for centralizing data storage, that our various communities of practice have community repositories and other solutions available to them that they intend to continue using, that it's likely to become more complicated rather than less complicated in terms of the range of storage solutions that are out there. And so this we accept as a given in trying to come up with an approach that works for single point of discoverability or access. And can you still hear this okay, Fuad?
Yes.
Okay, good. Next slide then. All right, so the solution properties are summarized on this slide, and there are sort of 5 general categories of components that we think are important to the final solution. The first I've already talked about, that it should be workable with respect to third-party repositories. And I think there are some characteristics of those third-party repositories that are going to be essential, but we need to minimize those so that we don't exclude a lot of solutions. The second is that it should enable search engines to access the metadata for this distributed NIST data. And this is to meet the data.gov requirement, for example. But also, it would be useful to make this metadata accessible to search engines of any type. And so whether it's Google or LexisNexis or whoever wants to provide access, that should be possible. The third is that it should specifically support the metadata that the OMB guidance provides, and so that's listed here. You heard a little bit about that already. But that beyond that, it should be extensible. And so while it should support a minimal set of metadata common across entries, particularly that mandated by OMB, it should also support, for our data, a discipline-specific metadata. And so we have materials metadata, chemistry, engineering, a wide range of different types of scientific data, and to be accessible and adaptable, in John's terms, we need to provide information that's appropriate to the discipline. There are also contextual metadata that are important for its use, and some examples are here. And finally, it should be extensible for a wide variety of purposes. And then the fifth category of properties that are important is, in order to meet some of the goals in the guidance memo, it should support persistent identifiers for not just the data objects, but for the metadata objects themselves, as well as for appropriate services, including web services, applications, and tools. A number of our scientific data sets are essentially an online resource, and that is, it's a query service that searches across a wide variety of flat files that themselves are distributed. And so we need to provide access not only to the flat files, but also to the services that are used to generate data on the fly. And so persistent identifiers for those objects are crucial as well. So those are the set of solution properties. In the next slide, this provides something of a logical model for this, and this is very much a work in progress. The bottom row here are the primary digital objects to which we're trying to provide usable access. Initially, we had imagined the use of DOIs, or digital object identifiers. After looking into it and some of the technical requirements, the constraints on DOIs as they're currently implemented mean that we probably will be using handles instead of DOIs because there are fewer constraints and better provisions for security and for authentication capabilities. And so I think we're in the process of rethinking that part of it. In any case, it's critical that the primary digital object in its repository, wherever it is, have a unique persistent identifier, and that the repository have a credible mechanism for maintaining those persistent identifiers. So there's one minimal requirement for any repository, is that they must have a credible PID scheme and the ability to maintain that and share those updates with us here at NIST. The layers above that, the rows above that, are all envisioned for metadata registry service here at NIST. So while the bottom row is distributed, we imagine that the top row being distributed but contained here all at NIST. And so the first layer would be the minimum metadata that conforms to the OMB requirements. Each of these metadata objects then would include in the handle the persistent identifier for the primary object to which they point. And we would like for the repositories to at least in their metadata headers to indicate that these objects are from NIST, so that one could find that by searching our metadata object for that PID. But in principle, that's not necessary. The idea then is that there would also be a hierarchy of additional metadata objects which all also point to in their handle the primary metadata object, and these would include the specialized metadata that I talked about before, as well as extensions to the metadata set. We're actually working with Johns Hopkins in developing a hierarchy for metadata objects of these types, so that we could have some convergence on the appropriate sets and types for this registry. On the next slide, this is just a very generalized scheme for the physical model that at NIST there would be a handle.net resolver and a digital object registry. We're working with Larry Lanham at CNRI on this aspect of it. And in the upper right corner, you can see the set of external repositories that will house the various data objects that we've been talking about. So a very simplified view of the scheme that we have in mind. In the next slide, which is the last slide, what we're trying to do is to assemble an interagency technical advisory group to work with us as we work through this implementation. As I said, we'll be working with Johns Hopkins on taxonomy and on CNRI on a pilot registry. It's a metadata registry, and associated tools that would be open source and downloadable. We intend to download that and implement that in the end here at NIST. March is the timeline for getting that operational demo in place. But we've been meeting with a variety of interested agencies. The Smithsonian and Department of Energy are examples. We're very much interested in talking with other agencies who would be interested in trying to develop a common set of specifications for this. So that would be the role of this technical advisory group, would be to meet with the project team that's doing the design and implementation of this pilot, so as to shape the operational demo in a way that the open source products that result would be of use to the agencies that participate in this.
I think they've run out of films.
And in the end, the idea is that if this approach is adopted by a range of federal agencies, that the metadata registries across those agencies would be interoperable and could be searched by a common access mechanism. And we think that that, in the end, would make federal data more easily accessible to everybody. So that's what we're up to. I wanted to share this so that we could see if there's anybody out there who's interested in hearing more about this and the possibility of joining the technical group. On the very last slide is the contact information, so that you can get hold of us if you're interested. So that's a very high-level view of the project. The goal is a demonstration platform for an interoperable metadata access point. The metadata registry would be used to populate the data.json file set that OMB is requiring and would be interoperable and conform to the OMB guidance requirements. And so that's what we're trying to